Hello guys. So today we have a problem related to inequality, or we can say let first we understand the problem, then we will proceed further. This sign is fractional part. As we all know that this sign is fractional part, and we have to prove that fractional part of square root of 1, root 2, root 3, root 4 and so on till square root of n square, and it should be less than or equals to n square minus 1 divided by 2. We have to prove prove this. So we'll start from analyzing the question till we will till then we will proceed further. So here what we have, like we have given number in a sequence. Like suppose if these are just 1 2 3 4 till n square, then we can easily find out its sum. Okay, sum of first n square natural number. But here we have given the fractional part. So what is the fractional part? Like if we have provided a number 2, so its fractional part is 0. How do we decide the fractional part? Actually, for every number, any real number, I can say any real number x, so we can represent x in its fractional part and greatest integer function of x. Like if x is 2.5, then fractional part is 0.5 and greatest integer less than 2.5 is 2. So we can represent every real number x belongs to real number in this way. Fractional part of x equals to x minus greatest integer of x. Here we have provided square root of 1, square root of 2, square root of 3, square root of 4, whole GIF, whole fractional part. Okay, so from there we can represent this as 1 minus greatest integer of 1 plus 2 minus greatest integer of root 2 minus plus root 3 minus greatest integer of root 3 plus root 4 minus greatest integer of root 4. We can represent these in this manner. So greatest integer of 1 is 1, so this is 0, 1 minus 1 plus root 2 minus greatest integer of root 2. Like if it is root 4, then it is 2. Okay, like root 4 equals to 2. Okay, so root 2 should be less than 2, root 3 also less than 2. So if we take GIF of these, then in their GIF will come out to be 1. Okay, so this is root 2 minus 1, this is root 3 minus 1, and this is 2 minus 2, this is 0. We will take integer p and integer p plus 1. Okay, integer p anything from g from 1 to n. Okay, 1 to n, or we can say it should be n minus 1. Okay, like just take 1 to n. Okay, now if we take square root of p square, then it come out to be p, and if we take square root of p plus 1 square, then it will come out to be b. Square root of p square is this p square plus 2p plus 1. So the middle number between these two integers, like p square plus 1, p square plus 2, p square plus 3 till p square plus 2p. Okay, GIF of all of these number is p. Okay, now we can simplify this question in a good manner. Like we have square root of p square plus I am taking just a number. Okay, I की वैल्यू यहाँ पे कहाँ से कहाँ तक जा रही है, 1 from where to where the value of I varies, I 1 to 2p. Okay, I की वैल्यू 1 से 2p तक वेरी हो रही है. तो अभी जो अपन ने ऊपर लिखा हुआ था, ऊपर क्या लिखा हुआ था अपन ने, स्क्वायर रूट ऑफ 1 प्लस स्क्वायर रूट ऑफ 2 प्लस स्क्वायर रूट ऑफ 3 प्लस स्क्वायर रूट ऑफ 4 till square root of n square. Okay, so can we write this in a double summation, like I am taking here square root of p square, square root of p square plus I. Okay, from where to where I varies, 1 to 2p. Okay, and p varies from 1 to n. Okay, so what we will get here, we will get p square plus, first we take p value is 1, so this is 1 plus I. Now we will expand, so this is square root of 1 plus 1 2, square root of 2, square root of 3. Okay, we will get expression like this, and this is fractional part, so we will apply also fractional part here. So for taking value of p, we will get root 2 and root 3, because p value 1, so 1, between 1 and 4 all these values come here. Okay, and if we take value of p equals to 2, then this is 4 plus I. Okay, then this is going to be root 5, root 6, root 7 and root 8. Okay, so now what you are thinking, that where the square root of 1 gone, where the square root of 4 gone, and if we calculate further, where the square root of 9, where the fractional part of 9 gone. Like if we calculate this number, fractional part of square root of 1 is 0, fractional part of square root of 4 is 0, and similarly fractional part of square root of 9 is 0. Okay, and if we take value of p n minus 1, okay, then this is n square minus 2n plus 1, this is n minus 1 square, so plus 1 till this will goes n square minus 1. Okay, because next one is square root of n square, that is integer. So basically if we are going square root of n square, so for this we need to put value of n minus 1 in place of n, because we are going just n square. If we are going till like n square plus 2 and plus 1, then we will write here n. Okay, so this is our simplified expression that we simplified here. I will write it down. I will write it down, this expression. Fractional part, square root of p square plus I is equals to 1 to 2p, and n equals to, p equals to 1 to n minus 1. Okay, so for every fractional part, can we represent this fractional part in the form of the real number and greatest integer part. Can we represent, like if we say this is p plus I, p square plus I minus p square plus I square root minus greatest integer of p square plus I. Sorry, I will. mm, So earlier we see that this p square plus I greatest integer is always equals to p. Okay, because from I value 1 to 2p, this p square plus I value is like this is, earlier we discussed this part, like this is root 2, root 3. So their greatest integer part is 1. Okay, and root 4's greatest integer is 2. So we will replace this number by p. Okay, p is equals to 1 to n minus 1, I is equals to 1 to 2p, and this is square root of p square plus I minus p. Okay, we reduced our expression like this. Now what we can do, like this is complicated. So like if we rationalize this, okay, like this is p square plus I minus p. Okay, if we divided by p square plus I plus p and multiply this by p square plus I square root plus p. This is a minus b, a plus b. So this is a square minus b square divided by square root of p square plus I plus p. So this is going to be I by I divided by p square plus I plus p. Okay. So this number is like this, p square plus I plus p divided by. So we will write it down here. 2p I divided by p square plus I plus p. And can we say that this number is less than, okay, p is equals to 1 to n minus 1 and I equals to 1 to 2p less than I by p plus p, because I just removed I here. If we remove something from denominator, okay, then the number will increase. So I removed I from denominator, so this number is greater than this. So this number is actually very simplified, so we can write it down as 1 to n minus 1 and I is equals to 1 to 2p I divided by 2p. Okay, so for first summation p is constant. Okay, so first we evaluate first expression. First expression like 1 by 2p summation of I1 to 2p. Now we know the summation of n is n plus 1 divided by 2 for first an integer. Okay, so here the value of n is 2p just. Okay, p is equals to 1 to n minus 1 and 1 by 2p into 2p multiplied by 2p plus 1 divided by 2. 2p to 2p cancel. and this is going to be p is equals to 1 to n minus 1, 2p plus 1 divided by 2. Or can we write this as p is equals to 1 to n minus 1 plus p plus 1 by 2. Okay, now we just separate these out. 1 to n minus 1 p, okay, plus 1 by 2 p is equals to 1 to n minus 1. Okay, so first n minus 1 term integer, n multiplied by n minus 1 divided by 2. Okay, and what is this? This is 1 by 2 multiplied by n minus 1. Okay, 1 by 2 n minus 1 बार ऐड हो रहा है. Okay, so we will common out n minus 1 divided by 2, and inside it we will get n plus 1. Okay, so this is n square minus 1 divided by 2. And earlier what we thought, that our expression that square root of 1 plus square root of 2 and fractional part of everything till n square less than equals to n square minus 1 divided by 2. We need to prove this simple expression. Okay, and we have proved. Like, I just added the less than sign, not equal sign. So when this expression is equal, so when the expression is equal, we prove the less than inequality. Okay, less than inequality. But when the function is equals, like if we put value of n equals to 1, then this is equals. Okay, this is 0 and this is 0. And is there any value of n that this is equal? No, not equal, because it is already less than that we show earlier. Okay, थैंक्स फॉर वाचिंग. आज के लिए इतना ही. चैनल को सब्सक्राइब कीजिए, लाइक कीजिए, कमेंट कीजिए. अगर आपके कोई डाउट है तो मुझे बहुत ही खुशी होगी उनका रिप्लाई करने में. एंड थैंक्स फॉर वाचिंग. कीप लर्निंग, कीप ग्रोइंग. जय हिंद.